Problem 24. Use the diagrams in problem 23 to answer the following questions. And we have 3 questions here. Now, if you look back at problem 23, here are the diagrams. You're shown 3 different mixtures containing particles, and these are all gases. You can tell because there's a lot of space between the particles. So it looks like the blue ones are nitrogen molecules and the red ones are oxygen molecules, if you remember your color coding. Now, what's really important in this problem is that you just remember that these are all gases. So let's go to the questions. Okay, the first one, what happens to the pressure in sample 1, that's this one, when sample 1 is heated and the volume is kept constant? Well, the answer is the gas pressure would also increase. If it's heated, then the gas pressure would also go up. It would increase. And you can get this from Gay-Lussac's law. Gay-Lussac's law says that for a fixed amount of gas at constant volume, the pressure of the gas is proportional to its Kelvin temperature. Gay-Lussac's law is valid for a fixed amount of gas, so the number of moles is constant. That's what we have here. The gas is trapped inside of a container, so it's a fixed amount. And it's at constant volume. You're not told that the size of this container changes at all, so the volume is constant. And those are the assumptions for Gay-Lussac's law. And the law says that the pressure is proportional to the Kelvin temperature. And what proportional means, let's blow this up a little bit more. What proportional means, oh, by the way, here's a mathematical form of Gay-Lussac's law, but the more important thing is the word proportional. Proportional means when one goes up, the other one also goes up. So if the temperature increases, then the pressure also increases, and it does so proportionately. So if you double the temperature, that means you also double the pressure. Now, likewise, if the temperature were to go down, the pressure would go down. So if you cut the temperature in half, you would also cut the pressure in half. So, if the sample is heated, that means the temperature goes up. Well, it doesn't tell us how much it goes up, so all we can say is that the pressure would also go up. Now, B is the next one. What happens to the pressure of sample 2 when the volume is halved and the temperature is kept constant? So here's sample 2. It actually doesn't matter. All it matters is that we're considering a gas. Okay, and this time it tells us that the temperature is kept constant. Okay? So the temperature is constant, and when the temperature is constant and the moles of the gas isn't changing as well, so you got your gas trapped inside this container, you're not changing any moles, then that's a Boyle's law problem. By the way, the answer is the gas pressure would double. So if the volume is cut in half, then the gas pressure would double. So the relation between pressure and volume is described by Boyle's law. Boyle's law says for a fixed amount at constant temperature, so constant moles, constant temperature, the pressure and volume of a gas are inversely related. So inversely related is different than proportional. Proportional means when one goes up, the other one goes up. If you double the temperature, you double the pressure. Inversely related is different. When one goes up, the other one goes down. So if you double the volume, you're going to cut the pressure in half. And likewise, if you cut the volume in half, you would double the pressure. So that's Boyle's law. Here's a mathematical statement of Boyle's law. So in this case, we're told that the volume is cut in half, okay? And so the pressure would be doubled. The gas pressure would double. That's a typical Boyle's law problem. Now the last one, C, what happens to the pressure of sample 3 when its volume is cut in half and its Kelvin temperature is doubled? So you cut the volume in half and you double the temperature. Okay, well, it's like a combination of these two. You know, you're talking about the gas and sample 3, it doesn't really matter. It's just a gas, okay? So you got some gas inside some container. You cut the volume in half and you double the temperature. Well, Gay-Lussac's law tells us that when you... Boyle's law tells you when you cut the volume in half, the pressure doubles. And then what about doubling the temperature? Gay-Lussac's law says doubling the temperature means doubling the pressure. So both of these result in doubling the pressure. Well, if this doubles the pressure and that also doubles the pressure, the combined result is that the gas pressure would quadruple. Okay, do you get that? If you double it once by cutting the volume in half, and then the temperature effect is to double what you now have, that would be quadrupled now. So you can think of it as an application of Boyle's law and then an application of Gay-Lussac's law afterwards. Or if you want to get creative, you can figure this out using the combined gas law. Okay, but the answer is that the gas pressure would quadruple.